Hello everyone. Today we will talk about how to hide C2 traffic when pen testing. People may hear about domain fronting, which uses CDN as a redirector and protector for C2 traffic. Nowadays, domain fronting is not well supported by CDN vendors and easy to detect. Today we will upgrade domain fronting to domain borrowing. We will show some tricks we found in some CDN implementations and chain them together to borrow a valid HTTPS certificate to hide our C2 traffic. I'm Junyu, focused on web security and pen testing. I have spoken at multiple security conferences. And my workmate, Tianze, he does web security research and threat teaming. He found multiple vulnerabilities in Microsoft and Safari. We are all from Tencent Security Xuanwu Lab. We will first see how previous people hiding the C2 traffic using domain fronting and domain hiding. And then we will show how HTTPS CDN works and how we use some features in CDN implementation to break the workflow and hide our C2 traffic. You will know what domain borrowing is and how it works. Finally, we will provide some detection methods and mitigations. One more thing. There are some rules in Palo Alto Firewall that can be used to detect and block domain borrowing theoretically. We will use a demo to show how we bypass the Palo Alto Firewall rules. Back to the year of 2015, researchers first proposed domain fronting. The idea is simple. CDN acts like a reverse proxy. CDN fetches resource based on the HTTP host header from the client's request and has nothing to do with the TLS connection. So the client first makes a TLS connection with the CDN server using a log.com certificate. And the HTTP request inside the TLS connection uses a forbidden.com host. The CDN will route back to the origin based on the forbidden.com rather than allow.com. So if there is no HTTPS decryption device acting like a firewall, the traffic looks like communicating with allow.com and cheats the firewall. There are some limitations of domain fronting. Asymmetry attack shows the way to detect domain fronting is decrypting the HTTPS traffic and check if SNI is equal to the host header. Some CDN vendors such as Google, Amazon, Cloudflare have already stopped supporting domain fronting. Last year at DEF CON, Eric proposed a new concept called domain hiding. The main idea is using a feature of Cloudflare to hide traffic. Cloudflare supports TLS 1.3 with SNI, which is currently an EFT draft. SNI will encrypt the SNI so that the firewall does not know what domain the client established connection to. As attacker can append a fake SNI to fool the firewall. This works because most of the firewalls do not support SNI, and Cloudflare allows the existence of both SNI and SNI. Domain hiding has some limitations too. For now, Cloudflare will refuse HTTPS connections if the client hello has both SNI and SNI. And SNI is not well supported as it is only a draft. Some enterprise environments, districts, countries have blocked or want to block SNI. We can see either domain fronting or domain hiding. There are some limitations. An ideal C2 must have following features. There are a large number of IP addresses for C2. C2 traffic is encrypted. establishing connections using high reputation domains with valid HTTPS certificates. These are already features of domain fronting or domain hiding, but we want more. The network traffic looks like normal HTTPS traffic, especially SNI is equal to the host, even decrypted. And the traffic should not be blocked in some districts. So there comes domain borrowing. Next, we will talk about what domain borrowing is and how it works. Let's begin with how HTTPS CDN works. HTTPS CDN works like a man in the middle. It needs private keys or custom domains to decrypt the HTTPS traffic and then routes to the origin. So first, website admin should upload certificates and private key to CDN and make the domain CNAME record point to CDN. A normal client request goes like this. First, the client tries to resolve the domain name and get one IP of the CDN edge server. Then, the client sends HTTPS client hello with cdn.example.com SNI to the IP. The CDN finds the certificate of cdn.example.com and establishes HTTPS connection. After establishing connection with cdn.example.com certificate, the client sends HTTPS encrypted data to the CDN server. The CDN server decrypts the data and routes the request to origin server based on the HTTP host header. In domain fronting, the HTTPS cert domain name differs from the HTTP host header. Then it behaves like communicating with one domain, but actually forward the request to another. The workflow of CDN may be very familiar to people, but I have some questions. Does the client really need to do a DNS query? Actually, if you already have an IP of the CDN's edge server, you can set an SNI in Cloud Hello and directly connect to it. Even the client can use another CDN domain for DNS resolution. If we have cdn.a.com and cdn.b.com in the same CDN vendor, mostly the two domains share the same CDN edge servers. So we can use cdn.a.com's resolved IP to establish connection with cdn.b.com. Another question is, can we register an arbitrary domain in CDN? Registering a domain in CDN does not mean we control that domain. We can only add a root rule in the CDN. We cannot modify the domain's DNS record. For example, we can register blackhat.com in CDN. When we skip the DNS resolution and forced to make connections to the CDN edge server, we can set blackhat.com in the HTTP request host header, and the CDN will route back to our EVL origin server. We found most CDN vendors doesn't have domain validation when people register a new domains. Some top CDN vendors will validate domain ownership. Azure and Cloudflare use DNS CNAME or NS to validate domain names. AWS CloudFront use HTTPS certificate to validate users' authorization to domain names. Other CDNs such as Fastly, StackPath, they doesn't have any domain validation. As you can see in the slides, we registered many famous domains in Fastly and StackPath, like Google, GitHub, Twitter, and so on. Register a domain in CDN seems useless. because we do not have the corresponding certificate. When CDN can't find the certificate, most CDN will send the default cert to the client. Some CDNs will send TCP reset to the client. We can see Fastly returns a default certificate with common name that default.ssl.fastly.net. So until now, we can borrow arbitrary domain CDN. We have SNI equal to host, which can bypass domain fronting detection. But we still do not have a correct HTTPS certificate because the CDN do not have the cert and private keys. We should set verify SSL cert to false to make a connection. There comes the question: how to obtain a valid HTTPS cert? Hackers can do it by hacking. We can either steal a valid HTTPS certificate or apply for a new one. If we get a web shell or we find an arbitrary file download vulnerability, we can read the certificate and the private key directly. If we can write an arbitrary file to the web server, or we can take over a subdomain, we can apply for a new HTTPS certificate with HTTP-based validation. Cloud storage is a perfect place to get a HTTPS cert with common name of a cloud vendor. Microsoft do not consider subdomain takeover is a security issue, so we use it as an example. A friend of mine found a Microsoft subdomain takeover, and we applied for a HTTPS cert and private key for that domain. We can see now the subdomain is not vulnerable at all, but the certificate is still valid. We upload the valid certificate to AWS CloudFront and pass the CloudFront validation. Finally, we can register ppe.verify.microsoft.com in AWS CloudFront and use it for our C2. Here is the demo. We use an open source C2 called Covenant. We wrote a custom implant template. We use the domain that is blogs.aws.amazon.com to get the IP of CDN H server. In the C2 traffic, SNI is equal to the host, and we have a valid certificate. Let's see how it works. We can see we have Microsoft domain in CloudFront. And here is our C2. We can see the address and SNI is the same, and there's no line. We generate the binary and run it in a Windows machine. We can see the HTTP host is Microsoft's subdomain, and the SNI in the client hello is the same with the HTTP host, and the cert is valid. We execute as command, and we can see the C2 works well. Okay, people may ask how to obtain a valid HTTPS certificate without hacking. Let Tianze give you the answers.
Hi, I'm Tianze. Next, I'm going to talk about how to obtain valid HTTPS certificates without hacking. Firstly, let's dive into how CDN distribute HTTPS certificates. We found there are two ways to distribute certificates. The correct way goes like this. The client wants to establish HTTPS connection with the CDN H server. So it sends client hello to the CDN and the SNI is set to cdn.example.com. Then the CDN looks up the certificate in its database. CDN query the database, select a certificate from the database where domain name is equal to cdn.example.com. Please note that the actual CDN database are more complex. We only use this table to demonstrate the workflow. Apparently, the first line in the database meets the condition, which shows the certificate of cdn.example.com is start.example.com.cert. And then the CDN will send the certificate back to the client in HTTPS server hello. Finally, the client can use this certificate to complete the HTTPS communication. And this is the correct HTTPS certificates distribution process. However, we found that some CDN vendors don't correctly implement wildcard certificates distribution process. Let's talk about the improper implementation and what attackers can do with this feature. An attacker can register static.example.com on CDN and doesn't need to upload the certificate of static.example.com. Then CDN will add a new line in its database like this. When the client uses static.example.com as SNI to communicate with the CDN will query the database. It will select a certificate from the database where certificate matches static.example.com. Please note that the query here is different from the correct one we discussed earlier. The wildcard certificate start.example.com.cdn search matches the static.example.com in the first line of the database. But this certificate was uploaded by Alice. Yes, this is the point. The certificate owned by Alice matches the domain registered by the attacker. And then the CDN will send the certificate which is owned by Alice back to the client. As a result, client can use static.example.com to establish a valid HTTPS connection with the CDN. In other words, the attacker borrows the wildcard certificate from Alice. So with this feature, attackers can register subdomains and borrow wildcard HTTPS certificates from other CDN users. We found that the StackPath CDN and CDN 77 does have the feature. So we can borrow wildcard HTTPS certificates uploaded by other users on StackPath CDN and CDN 77. We found there are some well-known domains with wildcard HTTPS certificates on StackPath and CDN 77. StackPath is a CDN supporter of JS Foundation. So there are some popular projects of JS Foundation, like Bootstrap and Awesome, post their static assets on StackPath CDN. These front-end projects are widely used in Alexa Top 1000 websites. And there are also some interesting websites on this CDN like Xvideos. Attackers can borrow their subdomains and valid HTTPS certificates to hide site traffic. use bootstrapcdn.com as an example. We can register any subdomains of bootstrapcdn.com, even a non-existent domain like static.bootstrapcdn.com. And when clients use static.bootstrapcdn.com as the SNI in the HTTPS connection, the CDN will return the wildcard certificate start.bootstrapcdn.com to the client. Then, the client can get a valid HTTPS connection, which looks like a normal connection of Bootstrap. In this slide, you can see we have successfully registered static.bootstrapcdn.com on StackPath CDN. And static.bootstrapcdn.com is a non-existent domain. You can see in the left screen. I use dig to query the DNS records of static.bootstrapcdn.com. The result shows that the domain doesn't have any DNS record. Then we use curl to force static.bootstrapcdn.com to resolve to an IP of StackPath DNH server and send a HTTPS request to the server. It turns out that the StackPath DNH server sends the certificate start.bootstrapcdn.com back to us. Apparently, the certificate is not uploaded by us, and it doesn't belong to us. But we can borrow the wildcard certificate from other user who uploaded it. Here's a demo. Shows how we use static.bootstrapcdn.com in our C2 agent. Here we use core nice C2 as before and write a custom implant template. Then register static.bootstrapcdn.com on StackPath CDN. The www.stackpath.com is the domain on StackPath CDN. Our C2 agent uses this domain for DNS lookup. The SNI and HOST in the C2 traffic are both static.bootstrapcdn.com with a valid certificate start.bootstrapcdn.com. Let's see how it works. We have registered a static.bootstrapcdn.com on StackPath. And set the origin to our Coronet server. The SNI is set to static.bootstrapcdn.com in stager code. And then we generate a C2 agent, download the binary, copy it to our Windows machine. And execute it. You can see the host handler in the HTTP request is static.bootstrapcdn.com. And then we are shocked the SNI in client hello is static.bootstrapcdn.com too. And the certificate is a valid wildcard certificate. The C2 agent is online now. Then we execute a shell command to pop a calculator. And since the C2 agent works well. So, what is domain borrowing? We give a definition here. Firstly, attackers register high reputation subdomains on CDN. Secondly, borrow valid HTTPS certificates. Attackers can borrow certificates from vulnerable websites or wildcard certificates from other CDN users, then combine them to hide C2 traffic and circumvent censorship. We did a comparison between domain borrowing domain fronting, and domain hiding. They can all use high reputation SNI and valid HTTPS certificate to communicate with CDN. By contrast, the advantage of domain borrowing is SNI can be same as the host, and domain borrowing doesn't rely on not widely supported HTTPS features such as ESNI, and this make the traffic looks like normal HTTPS traffic. Next, we will introduce some methods to detect and mitigate domain borrowing. An important signature of domain borrowing is that the client abandons DNS resolution before connecting to the CDN edge server. Therefore, for routines, you can compare the destination IP address of HTTPS connection with the DNS lookup result of the SNI in the firewall. For example, the client uses cdn.example.com as SNI to connect to IP 1.1.1.1. The firewall reads the SNI from the HTTP client hello and do DNS lookup with it, and get the IP address of cdn.example.com 2.2.2.2, which is not equal to the target IP address of the HTTPS connection 1.1.1.1. Therefore, the firewall can treat this HTTPS connection as a domain borrowing behavior and close the connection. There are also some suggestions to mitigate domain borrowing for CDN vendors and website admins. Domain borrowing uses many features of CDN, so for CDN vendors, the best way is to disable these features. CDN vendors can validate the custom domain strictly to avoid attackers borrowing high reputation domains. Distribute wildcard HTTPS certificates correctly can also prevent attackers from borrowing valid certificates from other CDN users. For website admins, if your website was hacked, you not only have to remove backdoors, but also check whether your HTTPS certificates have been abused. You can revoke your certificates and query whether the attacker applied for new certificates of your domain through certificate transparency. Next, we will show a demo of bypassing Alto firewall with domain borrowing. We use the latest Alto PanVM 10.0.4 as a demo. PanVM 10.0.4 is a next generation and HTTPS decryption firewall, and it supports HTTPS decryption from SSL 3.0 to TLS 1.3. We will also enable the HTTPS decryption in our demo. When we tested with Alto firewall, we found Alto firewall has signatures called anti-spyware evasion signatures, which has two following roles. The HTTP evasion checks if the result of DNS lookup host is equal to the destination IP address of HTTPS connection. The TLS evasion checks if the result of DNS lookup SNI is equal to destination IP address of HTTPS connection. And we set the policy of these two roles to alert all in our demo. If there are any HTTPS connection matches these roles, the firewall will alert. The anti-spyware evasion signatures can theoretically detect domain borrowing, but only theoretically, because of the improper implementation. There is a feature of anti-spyware evasion signatures. If Palo Firewall cannot resolve the domain in SNI or host, the connection would pass the firewall's check. For domain borrowing, the SNI and host can be any domain, even a non-existent domain. So we can bypass the anti-spyware evasion signatures. We use the following configuration in our demo. We use common-night C2S as before. The staging.faultawesome.com is the domain of the FoundAwesome project and is on StarPass CDN. Our C2 agent uses this domain for DNS lookup to find the IPs of CDN servers. And the C2 agent is at both the SNI and host to image.faultawesome.com and borrow the valid HTTPS certificate start.faultawesome.com from StarPass CDN. As the picture shows, the image.faultawesome.com is a non-existent domain which doesn't have any DNS record. Here's a demo. On the left screen is the Palo Firewall 10 VM. On the right screen is the Windows machine where we will run our C2 agent on installation. You can see we create a decryption policy named decrypt all with all TLS versions enabled. And we'll create an anti-spyware policy. It has anti-spyware evasion signatures enabled. This is the thread page, now it's empty. This is thread page, now is empty. There's no online C2 agent. The SNI is set to staging.faultawesome.com and we execute the C2 agent on the Windows machine. You can see the host is image.faultawesome.com. We execute a command to pop a calculator, which shows the C2 agent works well. And we go back to the thread page. There is no alert log. This means we successfully bypass Palo Firewall. And in the decryption page, we can see our C2 traffic. The SNI is image.faultawesome.com and the certificate is a valid certificate start.faultawesome.com. And the traffic looks like normal traffic of FaultAwesome. Finally, we will release the common-night implant template after the conference. And thank you for listening.